Hi everyone, my name is Ben Fulroth and the title of my final project is Improving Deep DTA, a published deep neural network model for predicting drug target affinity using a modern dataset and model fine-tuning. And so I've been a scientist for over 20 years in drug discovery, and at a very high level, drugs can be discovered by screening a lot of molecules, sometimes anywhere from hundreds to billions, against target proteins. What we're really trying to do is find binders to target proteins that are implicated in disease. And so one way in which you can measure the binding of a small molecule to a target protein is through the dissociation constant, as shown on the right. Once you get that number, you can then think about it and create another molecule, retest it, hopefully it's better. And so this particular paper that was published in 2018 was really interesting in that they showed that they developed a model whereby it takes the SMILE strings of drugs and the protein amino acid sequence, and using that they can actually predict the affinity. So I took their model and I was able to validate it and show that it indeed works, which is really cool. And so then I tried to apply this to my own work. And one of those ideas was to fine-tune the model to be able to predict low affinity fragment-like molecules. Just a brief primer on fragments. Fragments are smaller, and so the idea is that they can get into the nooks and crannies of a protein that larger, more elaborated molecules can't. And so unfortunately, these fragments are very weak in most cases, and they're hard to detect. So having a model like this would be really beneficial. And so my strategy was to take an already trained data set, which I trained using one of the models or the paper's provided data sets. I froze some of the layers, trained it, and unfortunately, no matter what I did, I could not get it to learn appropriately. And so unfortunately, this project didn't really work out as intended, but I learned a lot, and I hope you did too. Thank you very much.